All right, today we are working on our last objective of this unit. So we need to make sure that we have been preparing and understand any mistakes we made on other objectives. So next week we will be ready for preparing for our test. Today's objective is C06. I can find the least common multiple of a set of numbers. So we talked about the greatest common factor, and now we're talking about the least common multiple. So it can be confusing. So when we talk about factors, we talk about that greatest common factor, the GCF. And when we talk about multiples, we talk about the LCM, the least common multiple. So we're going to go through trying to make sure we keep this straight, which is which and when do we use them. So the first thing is we need to do our definition of what a multiple is. A multiple is a given number can go into. So a multiple is the number a given number can go into. So if you're finding the multiple of a number, what can you multiply it up to? So if I said our multiple is our given numbers of 4, what would be some multiples of 4? Colin?
4, 8.
So 4, because 4 times 1 is 4. And then Colin said 8. 4 times 2 is 8. Cole? 12. 4 times 3 is 12. So those are all the multiples. What can you multiply that number by and get a new number? So the multiple is what you're getting when you're multiplying it by other numbers. Cole? Or Sam?
Can you just do 1? Or is that not the least?
Well, multiples of 1 would be 1.
Yeah.
So that's kind of a goofy one. All the other ones you can multiply, when you multiply by 1, 2, 3, 4, 5, you get different numbers. That was a good question though. So remembering how factors and multiples differ can be tricky. Here's a comparison. What are the factors of 12? Leah? 4 and 3 are factors. What else are factors of 12? Ethan? 6 and 2. What else is a factor of 12? Andrea?
1 and 12.
1 and 12. So those are factors, are those numbers that you can divide that number down into. So when you're looking for the factors, you're dividing it down. When we're looking for the multiple, we're multiplying it up. So what are some multiples of 12? Caitlin?
24.
What's another multiple of 12? Paisley?
8.
Is 8 a multiple of 12? Can I multiply 12 by something and get 8? What would be a multiple of 12? Multiply it by 1 for me. 12. Your first multiple is always the number itself, because you can multiply any number by 1. So your first multiple is always going to be that number. What's another one, Maddie?
6.
Is 6 a multiple of 12?
No.
Can I multiply 12 by a number and get 6 for my answer? Try it again, Maddie.
2.
You're giving me factors. You're breaking it down, dividing it down. When we find multiples, we're getting bigger. So we multiplied by 1 and got 12. We multiplied by 2 and got 24. One more try, Maddie.
48.
48. If we multiply 12 by 4, we get 48. So when you're finding those multiples, it's multiplying it by a number to get a bigger number. Briggs?
72.
72. If we multiply 12 by 6, we get that 72. There are lots of multiples, and we don't want to waste all of our work time listing off all the multiples of 12. So we have, just like we had different ways to find factors, because we know our brains all work in different ways, and what's the easiest way for me to find it? There are different ways, different methods to find the least common multiple. So when we say the least common multiple, we're going to be comparing numbers. Just like when we found the greatest common factor, we compared two numbers, and what was the biggest factor that they shared? Finding that least common multiple, we're going to find what is the smallest multiple that those numbers share together. So let's look at method 1. I'm going to move my screen up a little bit. Method 1, finding least common multiple using the MCL method, using 6 and 10. So our first step is to list multiples. So I'm going to look at 6 and I'm going to look at the 10. And I'm going to make a list, not to infinity, but I'm going to, sometimes you could do 5 to 10 multiples for each number, always starting with 1 and going in order. So what is 1 times 6? 6 times 2? 6 times 3? 6 times 4? 6 times 5? 6 times 6? 6 times 7? That's all I have room for right here. We're going to see if we have to go any farther. So now we're going to list off our multiples of 10. What's 10 times 1? 10 times 2? 10 times 3? 10 times 4? 10 times 5? 10 times 6? And we're going to stop there. So our first step was to list those multiples. Then we want to list, you know what? Let's go a little bit bigger here with our 6s. After 42 is?
48.
Then what?
54.
Then what?
60.
60. Okay. So now we can look to see what are some common multiples in those two lists that we had. Naveen?
30.
What's another common multiple they have? Paul? 60. So just going out as far as I did, I found two common multiples that both those numbers multiply into. So that's what the C is. What do they have in common? Our L is which one is the least, the smallest multiple. Which one is the least whole?
For what one? For both? No.
For both, we're comparing them both.
6 and then 10.
These are our multiples. 30 and 60 are the common ones. Which is the least common multiple? 30 is that smallest one. So our least common multiple between 6 and 10 would be 30. They both can multiply up to 30. They have that in common. There is no smaller number that they have in common for their multiple. Izzy?
Is it kind of like the factors, just like opposite?
It's kind of like the factors, yes. So when we were finding that greatest common factor, you had to circle the common factors and then you found the greatest one. This time we're circling the common multiples and we're finding the smallest one. So they say least. A lot of times we say smaller, but least is that smallest number. Then we have that prime factorization. Just like when we did our greatest common factor with the prime factorization, we're going to use those primes a little bit differently. So look to how we use the primes this time. It's going to kind of look the same, but it's different. So pay attention. We're still using that 6 and 10. We want the primes for our 6. What are the primes to get me 6? Leah? 2 and 3. So we have that 2 times 3. Then we need to find our primes for 10. What are the primes for 10? Nathan?
5 and 2.
Yep, that 5 and 2, 2 and 5. Here's where the difference comes in. we need to multiply, well, we need to see which primes they have in common, and we're going to count it only one time. So I see that there are a 2 and a 2, so I'm going to come over here and I'm going to write that 2 one time, because they both have a 2. Both the 6 and the 10 have 2 as a prime, so I'm going to write my 2 one time. They have that in common. Then I'm going to write the 3.
Why just the 3?
Because it is one of the primes that go into it.
Yeah, I know.
So we're only counting the 2 one time because they have it in common. So we only have to count it once. There's 1 3 here, so we're going to move that over. And there's 1 5 here, so we're going to move that one over.
I'm guessing there's not a specific order. That's what I meant.
No, it's not a specific order. It's multiplying. We talked yesterday about how it doesn't matter which way we multiply, we get the same answer. So then we need to multiply out the primes. So 2 times 3 we know is 6. 6 times 5 is 30. Look at that. Same least common multiple.
Either way.
Just like when we were doing greatest friends. Just like when we did greatest common factor. It doesn't matter which method you use as long as you use it correctly. A lot of times when people do that prime factorization, they forget that you only write the 2 one time. And they write 2 times 2 times 3 times 5. If they share a prime, you write it once. Okay, so let's work through a few of these and see how we do.
Joe McGeary and Gigi Hemrick, please come to the office. Joe McGeary.
All right, so let's look. We're going to use both methods. So work it out on your paper right now. The first method was listing the common multiples. So you want to list those common multiples. So that first one is the M. And then the C, circle what they have in common. And then tell me what the least common multiple is.
On the other side, will we have to use both of them and just one?
Just like with the greatest common factor, you're going to use the one that works best for you. Okay. But I want us to understand both methods.
How far do you
Remember with our 6 and 10, we went out as far as we thought we should go. Okay, it's not a you have to go out to 100 multiples. Okay, that would take us forever. Go out a handful, 2 handfuls, and see, then go back and see, did I find any common multiples? You might not have found a common multiple, and you might need to go farther then. So I'm going to start listing our multiples of 15 while you are working on it.
Oh, I should have messed up.
So one of the things I just saw a light bulb go on for somebody, like, oh, I did the wrong multiple. I didn't multiply correctly. So if you're having a hard time finding a common multiple, go back and double check your math. Make sure that you're multiplying correctly. That's usually one of the first problems that we can find is our simple math mistakes. So I went out this far for my 15 and my 21. Step number 2 is to find what they have in common. So I'm going to compare my numbers and see where I see something in common. For as far as I went out, I can see they have 105 in common. And then my hand got sore, I got tired, I stopped going out. Ran out of room on my paper. Do I need to go any farther?
No.
Who said no? Who said no, I don't need to go further? Why don't I need to go any further, Caitlin?
Because you don't need to go any farther, because if you go farther, that means then they'll get bigger. And you want to find the least number.
Exactly. If you find a common multiple right away, you don't have to go any farther because you want the least common multiple. You don't need to put on bigger multiples. You can just stop right there and say, oh, 105 is my least common multiple. I don't need to list 2 or 3 common multiples. I just want the smallest one, that least common multiple. So now let's look and see what it would look like if we did our prime factorization. So we're going to use those same 2 numbers, 15 and 21. What are my factors of 15?
5 and 3.
5 and 3. What are my factors of 21? Yeah. 7 and 3. So remember, when we get to the bottom and we have full primes, we write them like this. What is my next step? Maddie?
Finding the common.
The common prime. So we need to find our common prime. So we've got a 3 and a 3. So I'm going to write 3 one time because they share a 3. There's only one 5 and there's only one 7. So now I need to multiply 3 times 5 times 7. 3 times 5 is 15. Times 7 gives me 5. 105.
This can't be no.
Yes.
Also, so we have how we did the 15s. You could also look up there and count 7 times. Multiply for 15.
Yes.
You did 15 7 times.
Yes. Okay, so that's how we do both of them. Let's do one more. Maddie?
What if you get the same, least, but it's wrong? So you do both methods, but it's still wrong, but you got the same.
The chances of you doing both methods incorrectly in the same way is really small.
Okay.
So the chances of it happening if you do both methods, chances are they're not going to match if you're doing something wrong. Okay? And if it does, then when we correct, you learn from your mistakes. Sam?
On the next one, I know this is somehow wrong, but I got 30 for it. The next one. I got 30.
So I can tell you right now,
There's a bunch of
18 times 2 is 36.
Yeah.
So we're going to see. Okay, so I love that you were working ahead with it. We're going to see where you went wrong. First, we're going to do our first method where we find the multiples. We're going to find the multiples, then we're going to find what they have in common, and then we're going to find the least of them.
Yeah, I just used one of them.
Yeah, that's fine. So list out your 9s, your 15s, and your 18s. What did I forget? I love that you're double checking my work. It's always good to double check work. Did I do it correctly?
Yeah. I was looking at 9.
Okay. So those are the multiples that I went out to. After listing multiples, what is the next step? Colin?
You find the common ones.
Find the common ones. And when I'm going through it,
90.
I see 90 is in common. Are there any smaller common multiples? Yeah, I don't think so. Because we're looking at that 18. 18 and the 15 really don't match up until they get to 90. So my least common multiple for all three is 90. Now this is the one that Sam is really looking forward to, seeing where his mistake happened with the prime factorization. So we've got 9, 15, and 18. What are my two primes for the 9, Sam?
3 and 3.
3 and 3. So we know that's going to be 3 times 3. What are my primes for 15? Grace? Owen? 3 and 5. 3 and 5. So that's going to be 3 times 5. What are my primes for 18? Ethan? 9 and 2. Is 9 a prime?
Yeah, no.
No, so I can break it down even more. So it's going to be 2 times 3 times 3. So this is a good one for us to really understand, and I think I know where your mistake happened. We have to match up the primes. So we're going to match up this 3 with this 3 with this 3. So I'm going to write it one time. Am I going to write another 3? I see a 3 and I see a 3.
Yes.
Do all 3 of the numbers have another 3 in them?
No.
No. You can only match them up if they all 3 share that prime.
But I did that in the Yeah, I did too. I only have 1 3. I got 3 times 5 times 2. That's not nice.
So 3 times 5 is 15. Times 2 is 30.
And then if
Right. So I said you can't match them up. So here I took out 3 3s and I only put 1 3. So now what I have to do is I have to list every other prime that they all 3 don't share.
But no. I think you can match 9 times 5, which is 45, and then times
You should have 3
90.
3s.
Because that's what I.
Oh, my goodness, you guys are so smart.
You not write that. Is it?
So if you can match up any primes that you can match up, so we matched up this with this with this, then we matched up this with this. So we got 2 3s are written down there.
Yeah.
And then you have your 5 and your 2.
Oh, that makes sense.
Yeah.
I'm kind of so confused a little bit. It's just with the last part. That's all.
Yep. So the way, look at it written like this. If we were to write, oops, that's a 3.
Because if you use 3 3 and it gets 2.
So if we put them on top of each other, what do I have?
It's another
3. And then we have a 3, whoopsie. So we're going to match up those 3s and we're going to match up those 3s.
Oh, so if you have 2 of them, it's still
Yes. If you have 2 of them, it still counts.
That makes sense.
So if you line them up and you can draw the circles around them, then that's the best way to do it. So actually, let me rewrite this even cleaner. So we had 3 times 3, and then we had 3 times 5, and we had a 2 times 3 times 3. So line them up. Okay? And then you can see, okay, I've got a 3 here, and I have a 3 here, and I have a 2 and a 5. Okay? Are we feeling good about that?
Oh, yeah.
All right, any questions, Caitlin?
If you do make that mistake, because if you use 3 3s, then it will get way too high.
Yes, and that's your first clue. If you look at a number and go, whoa, that seems kind of crazy of an answer, go back and double check your work. A lot of times when things just seem off, you made a simple mistake. So that is a great thing. I'm glad we experienced that because we were like, oh, that's a way too big of a number. Let's go back and see what I did wrong. Sam, hold on one second. That is it for our lesson today.